you, Kulkarni sir.
Thank you very much, Trupti madam. Friends, I must say that the machines versus human battle is not new to us. They correctly depicted in various movies like Terminator, Matrix, Avengers, Space Odyssey. The perils of artificial intelligence are also mattering a lot when we are modeling them. The perils like autonomous weapons, AI bias, invasion of privacy are threat to mankind if not been taken care of. Who else can better explain this by Dr. David Wood, sir, the chair London Futurists, writer, consultant, the PDA smartphone pioneer, Symbian co-founder, transhumanist from London. And sir's topic today is Beyond Today's AI, the promise and peril of artificial superintelligence. Sir is having the background in designing, architecting, implementing, supporting, and avidly using smart mobile devices. This includes 10 years with PDA manufacturer PLC, 10 more with smartphone operating system, especially Symbian Limited, and years as CTO, that is technology planning lead for Accenture Mobility. He is the author and lead editor of 9 books, and the most recent book is REFT 2035. The previous books includes The Abolition of Aging, Transcending Politics, and Sustainable Superabundance. He is the principal of from 2009 till Prita Wisdom is an independent futuristic consultancy and publisher. Sir, thank you very much, sir. It was always a great pleasure to listen to you. And thank you very much.
Is at DW2. The topic today is Beyond Today's Artificial Intelligence, the promise and the peril of artificial super intelligence. And what do I mean by this? It's not just today's AI, which can be described as narrow, which means that today's algorithms and systems are good in particular domains. You can have an AI, which is very good at playing chess, and another AI, which is very good at interpreting medical scans. Yet another AI may be good at navigating on a map from one point to another. But no AI is yet generally intelligent. But I'm looking forward to a time when we will have systems that can match human abilities in all aspects of intelligence. And then shortly after that, potentially these systems will be super intelligent, leaving the intelligence of mankind behind, by which time we humans will no longer be the smartest species on the planet. People have very different views about this. Some people say it will be a very wonderful development, and these systems will be able to help us solve long-standing, deep problems of life, such as providing a cure for cancer with their great intelligence, providing a cure for aging, helping us solve climate change, helping us solve the problems of inequality and politics. But other people, distinguished people, say, wait a minute, be careful. These systems will be very dangerous. How dangerous? End of the world dangerous. There is a third viewpoint, which is probably the majority viewpoint, which says this talk is premature. Artificial superintelligence isn't going to happen anytime soon. Some people say it can never happen because we humans have got some unique divine spark which no software on any computer could ever match. Others say it will be possible, but not for centuries. Well, let me give you my brief answers, and then I'll explain in more detail. I think it is possible that artificial superintelligence will happen within just a few decades, certainly well within the careers of many of the students listening now. However, if we are thoughtless, if we are not careful enough, that artificial superintelligence could be very dangerous and will do things that we humans did not plan and did not wish. However, if we think enough in advance, if we are collaborative, if we apply the team sport of humanity, to refer back to a question that was just asked. If we do that well, artificial superintelligence should indeed be wonderful. And in the next 30 minutes or so, I will try to justify these 3 points of view. I'll start by referring back to my professional career. As you heard, I started in the mobile computing industry 25 years ago. My business card did not say futurist, it said software architect. I was involved in working on the device on the left, one of the first successful handheld computers. And the company I worked in, Symbian, which was based in London, was at the time working on an incremental improvement to that Series 3 device, something called the Series 5, which had a better screen and a pen. I'm not sure if you can see my video, but I still have one of these devices with me and use it from time to time. So as well as being a futurist, I am sometimes a passist as well, using a device which is now more than 20 years old. But anyway, the point is this. We in Symbian realized that our world in mobile computing was about to be disrupted, deeply disrupted by a new trend. And that pattern of disruption is the one I'm going to talk about for artificial intelligence too. We realized that something as depicted in this picture would come to pass. This picture is now 22 years old. We realized that the trend of our business of computers becoming smaller and more mobile was going to be intersected, was going to be collided or converge with another trend, the trend of the mobile phone industry having devices that were increasingly smart. And that disruption was going to change the market for handheld computers. Eventually, we realized, we're going to change our own software. We're going to ensure that our software, known as Epoch or as Symbian OS, after the name of the company which was founded at that time, that it would support as positive feedback cycle the needs of application developers for mobile phones as well. So that was our vision. It took us a time. By the middle of the first decade of this century, we were selling very well, but for a long time, the industry kept using older software, older devices known as simpler phones, dumb phones, or feature phones. But eventually, our software broke through after long periods of disappointment, when it seemed that our software vision was premature, and when many people were even denying that the mass market would ever want to use smartphones. And people still said then that only a minority of people would want to have a phone with a big screen and with applications. But finally, after 7 years from the foundation of the company, we, along with our partners such as Nokia and Motorola, and at the same time, some competitors like BlackBerry RIM and Palm were doing very well indeed. Until we were no longer doing so well, because there was a second wave of disruption from new companies that had even more powerful hardware and software, companies such as Apple's iPhone, dating from 2007, and Google's Android. I could spend a long time talking about this picture, but let me just say, this is an example of a very important general principle. The future arrives in disruptive waves. By the way, each wave has a lot more software in it, as in the phrase, software is eating the world. Unless your company is good at software, unless you have people in your team who are excellent in software, you will be left behind and outcompeted, or in the phrase, you will be eaten. The first set, phase 0 of the phones, had relatively few apps, perhaps a snake game and very simple contacts management. The software that my colleagues and I created along with the competitors in that space had significant software applications, web browsing, email, agenda, scheduling, many games. And these devices were mini computers in their own right. But looking ahead, the next wave were supercomputers with 10 times or more hardware and much more powerful software. If I look ahead to the next wave, the most powerful application in the next 10 years of phones will be the AI assistant. And the phrase will become software written by AI is eating the world, meaning unless you have the best AI helping your human developers write good software, you will be outcompeted. So if I summarize the findings from my 25 years in this industry, findings that I believe apply to all breakthrough areas in technology, including artificial intelligence. Disruption is different from being an incremental step-by-step process. It goes through a slow and disappointing phase followed by a fast and furious disruption. It requires building not just new technology, but building a whole ecosystem of partners and infrastructure and feedback loops. Again, that's a reason why new change often takes longer at first than expected until that ecosystem is in place, and then it goes faster than was expected. Disruption, as I mentioned, happens in waves, with each wave having typically new core ideas, new tools, and new people. And finally, disruption is by no means predetermined in terms of its outcome. It very much depends on human actions as well. Let's now draw the similar picture for the future of AI. It's a slightly different picture, but the same principle, multiple waves. This first wave is the wave of classical AI, based on logic, based later on probabilities, based on experts writing down their knowledge in a set of rules together with exceptions to the rules. And this was commercially significant from the 1950s and 60s and has become more significant with each passing decade. I'm not particularly talking about that wave today. I'm talking about the second wave, which is the subject of your conference today and over the next 3 days, the subject of deep learning and neural networks. Unlike smartphones, that too had a slow start over many decades. People in the 1940s already had some of the ideas, but most of the attempts to develop deep learning and neural networks were failures, apart from a few specialist examples. And as in the midst of these disappointments, some artificial intelligence experts, such as Marvin Minsky and Seymour Papert, some of you may have heard of them. They are part of the grandfathers of artificial intelligence. They even wrote a book in 1969 which stated that neural networks or perceptrons would never amount to anything important. People should keep going with the current framework of classically defined logic and probability. However, by 2012, there was sufficient big data which was labeled, which could be fed in to training algorithms. There were also improved hardware, such as GPUs, which led to great breakthroughs from 2012 onwards. And people were, in the next few years, surprised again and again. Oh my goodness, this new system is actually outperforming classical AI in so many ways. And simple modifications of the basic idea of neural networks led to unexpectedly good results in more and more fields of inquiry. Convolutional neural networks were very good at recognizing images. Recurrent neural networks were very good at understanding speech, and so on for speech translation. But I'm not here to talk about that wave either. I'm here to talk about a next wave of artificial intelligence, which may be the next step towards, artificial general intelligence. And people will be even more shocked at how quickly that wave produces wonderful breakthrough results too, once it has started. And we will look back at today's system rather quaintly and fondly, saying it's rather good old-fashioned deep learning, just as today's deep learning experts look back at classical AI rather fondly and say, yes, good old-fashioned AI. There are people who deny this. There are many experts, so-called experts, professors in deep learning who say that there will be no new big breakthrough wave, such as artificial general intelligence, anytime soon. But I caution you all, be careful when you hear such denials. There are 6 reasons to be cautious about any dogmatic claims about artificial intelligence. There's a long track history of failed predictions. Yes, some people have been far too optimistic, predicting breakthroughs sooner than actually happened. Equally, there have been many people who have strongly predicted that breakthroughs would take 20 years into the future, and subsequently they happened much more quickly. I'm referring to things like software that outperformed human players in games such as chess and then more recently Go. It's true, many companies do overhype their product, claiming it has more artificial intelligence capabilities than is actually the case. It's true, many business people have been deeply disappointed that consultancies and products don't live up to what is now seen as their hype. There is a lot of overhype, but there is some underhype too. There are some companies who are working on artificial general intelligence in practice who are afraid of government oversight. They're afraid of politicians being clumsy, as politicians often are in their regulation systems, and they are afraid that these politicians will interfere if they believed that artificial general intelligence might be built anytime soon. So these companies sometimes underhype their products. Consultancy reports sometimes minimize talk about people losing their jobs, even though there is good evidence that more and more people will lose their jobs with better artificial intelligence. These consultancies don't want to frighten the clients of theirs who are paying good money for the research reports. So they say, yes, there will be some disruption, but not too much. And people get locked into their present paradigm, unable to see the strengths of new paradigms. This has been the cause of so many business failures. It will be the cause of many academics also missing the next potential. And finally, people are often quite guided by their underlying personal philosophies. And many people have a view, perhaps from their religious backgrounds, that humans are somehow uniquely special and no mechanical or electronic or silicon system could ever match. Especially they often refer to their children. They see the wonderful things that their young children can do, and they say this is beyond any software's power. But I caution people there. In the past, what people thought was impossible for software to do has been subsequently done many times over. And I remind you that when a magician does a trick, often we are completely dumbfounded. It's astonishing what the trick is, and we sometimes even think they must be supernatural or spiritual or miraculous or divine. But then later, when we find the trick, then we say, oh, it's actually not so wonderful after all. It will be the same, I believe, with many aspects of human intelligence, including, for example, music. Many people said in the past that music was so wonderful, no software could ever understand the depths of human emotion required to create wonderful music. But we have had software from people like Professor David Cope, whose software studies the music of people like Mozart and Bach, and then produces brand new music in the same style. And when people hear it for the first time, they sometimes say, this music is so wonderful, it touched my innermost being. And then when you tell them it was written by software, sometimes they splutter, they change their mind. They say, well, actually, I knew it was a bit robotic and clunky after all. But if you do a so-called musical Turing test, when you have 3 bits of music, one written by the original Bach, less known perhaps, one written by a modern human composer trying to emulate Bach, and the third written by the software, and you play it to an audience of people who don't know which is which, they will typically pick the one by the software as being the best of the three. More recently, software written by OpenAI has targeted many other types of music, such as folk music in the style of Simon and Garfunkel, rock music in the style of Elvis Presley, classic pop in the style of Frank Sinatra, pop in the style of Katy Perry, and so on. I listen to it. I don't think it's very good yet, but hey, I know that it's written by the software. I think it's coming along in leaps and bounds. What's driving the progress is positive feedback cycles. As we created in the software industry for smartphones with the positive feedback cycle of networks and devices and application developers and application stores, in the same way, technology and society has progressed by positive feedback cycles. The Industrial Revolution started when people were able to take advantage of steam power to build better machines that could harness the energy from the coal more readily. That machinery built better tools, which could then build better machinery, which could build better tools. The Third Industrial Revolution saw improvements in computing, which were initially hard to create. Computers needed to be assembled by hand, and hammers and rather simple tools. They needed to be designed on paper and pencil, but with each generation of computer, it has allowed subsequent generations to be designed and manufactured more quickly, more capably. It's been the same with software. Software was written by humans taking advantage of software tools such as compilers, debuggers, analyzers, profilers. And each generation of software builds better tools, which builds better software. That's in the past and in the present. I'm now looking at the present and the future. AI is built by humans working in teams, but using other tools to help them. And the AI tools are getting better and better, which means that AI will get better and better pretty quickly. I'll give some examples. Google's Brain team, led by Jeff Dean, have created AutoML, which is machine learning software that can write designs for machine learning software given a problem specification. And these human researchers, as stated in this newspaper article, have taught machine learning software to build machine learning software that in some instances is more powerful and efficient than the best systems the human researchers themselves can design. Positive feedback. A second example, this is referring to 4 quadrants of the ongoing Fourth Industrial Revolution. In the nanotechnology quadrant, we have better chips, better chip design, which allows our artificial intelligence software to run faster. But the artificial intelligence is now able to help better chip design. As reported here in Technology Review, Google is using AI to design chips that will accelerate AI, because the task of doing complicated chip layout is like solving 3D Tetris. Another example from this same diagram, improvements in artificial intelligence will allow us to improve our understanding of models of what's happening inside the human brain. It will allow us to make sense of data from lots of scans coming from the brain, fMRI scans and PET scans and so forth. And then when we understand the human brain better, the PhDs from neuroscience that work in many of these AI companies will lead to better AI. So the left improves the right, and the right improves the left. The bigger picture here, why I believe the improvement in technology is bound to improve and continue speeding up, is because we have more people in the world than ever before, who are educated to higher levels than ever before, who are networked together so they can benefit from each other's ideas around the world, a bit like we're doing today with speakers from around the world feeding in a network to this educational program. People with this knowledge build better tools, better technology, and the technology builds better networks, and the technology builds better education systems. So that's why we have more scientists active than ever before, more engineers active than ever before at higher levels, not just in a few countries, but in almost every countries in the world. We have people operating at higher levels of ability. We have business people who have learned how to turn technical ideas into successful businesses. We have designers who are able to turn raw technological ideas into products that have good user interfaces, and we have more educators. Therefore, we have more artificial intelligence and deep learning driving the acceleration in technology in almost every field and the acceleration of disruption. One example of that is from another recent newspaper headline: AI algorithms are starting to teach AI algorithms. It's not just that software can share its insights with software, that's easy. It is that, slightly different from what these pictures imply, it is that AI systems can increasingly teach humans, and occasionally human teachers need to step in and help, but more and more people can learn automatically. Another example. Another example. I'm hearing a bit of background noise. Thank you. Another example. Can you students work out what this woman politician is saying by looking at her lips? Even the best human lip readers struggle when they have no help, when they don't hear anything at all, when they don't know the context. Best human lip readers can only get on average 1 in 8 of the words correct, which is not surprising given that this comes from a large set of BBC public programs, news programs, documentaries, and so forth, which has nearly 17,000 unique words. So if you're guessing each word, you would only get a 1 in 17,000 chance, whereas Google's DeepMind software was able to get at least half the words right. But this is the really interesting point. Before you can train software by feeding it data, you need to have good data. And most of the training data, most of the videos that's around, they have often the video and the audio slightly missynchronized, a few fractions of a second different. And if you're trying to train from that, you will never get good results. You have to have it exactly perfectly aligned. So Google's DeepMind used another AI, first of all, to check that all of the data was lined up. Painstaking task that would have taken humans a great deal of effort. One AI did that data cleansing before the second AI was able to produce this remarkable result. One more example of how positive feedback can accelerate progress. I wonder if you recognize any of the people here. Actually, some of them are made up by software. I wonder if you can know which are made up and which are real. Actually, they're all made up by software using this system of two networks having an adversarial relationship. One is a kind of an arms race. One of the network is a deep network. Here we're only showing a few layers, generates pictures of humans, not real humans, and another piece of software is able quite quickly to know which are the made up ones and which are the real ones. But over time, both of the networks improve, and out of this arms race, surprisingly good results happen. It's a bit like a human counterfeiter if they were creating artificial high denomination rupee notes. To start off with, it probably wouldn't be very good, and the police could quickly discriminate the fake ones with the real ones. But eventually the criminals who are making these fake notes would get better, which would mean the police would have to get better at discriminating which were the fakes. And over time, the two of them both improve. Established experts in deep networks, such as Jan LeCun, one of the pioneers of deep networks, who is now head of an AI research lab in Facebook, have said this is one of the most interesting ideas in the last 10 years. So there are lots of feedback cycles, but still you may wonder what's needed to come from today's AI to tomorrow's AGI. And in this slide, I will set out the things that are necessary. Improvements in hardware will probably help. More powerful CPUs or GPUs or dedicated hardware chips such as the TPUs, tensor processing units devised by Google, and there are other new chips created by very promising startups. We might even have quantum processing units in the not too distant future once quantum computing works. That will help, though I don't think that's critical. It will allow people to do more experimentation more easily. I think the biggest breakthroughs will come from analyzing more data which is generated or cleaned up, as I've just mentioned, from another AI. But the most important things will be breakthroughs in insight into how AI will work in the future, possibly by copying more from the human brain's biology, not just copying neural networks, copying things like Jeff Hinton has spoken about, capsules, or other possible neuromorphic computing. Perhaps copying features of human emotional intelligence. There's already a large field called affective computing in which software can understand human emotion and mimic human emotion and can manage and manipulate human emotion. As that improves, that could have breakthroughs as well. Some people say we will have breakthroughs by studying what makes conscious animals and humans actually feel emotions rather than simply having mechanisms. Possibly when we study that, we will have insights to allow our software to break through. Other people, such as the researcher Judea Perrell, believes the breakthroughs will come from studying not just patterns of correlation, but inferring which aspects cause others, distinguishing cause and effect. Some people have hopes for large data sets of common sense knowledge. The idea is that once the data set gets sufficiently large, it will be able to learn more and more by itself. That hasn't happened yet, but may happen in the not too distant future. A very promising possible set of breakthroughs is known as transfer learning, of which Google's DeepMind have done some remarkable work in the last few years, in which software that is trained for a long time on one problem domain can quite quickly reapply some of that learning in a brand new field. So they will no longer need big data, but can learn from sparse data. And the seventh possibility is that actually artificial general intelligence might emerge simply from modules of simpler intelligence networked together in new ways. We don't know which of these breakthroughs will be significant, but the point is that many people are working with lots of commercial backing behind them in each of them. How many of these breakthroughs will be needed to get all the way to artificial general intelligence? We don't know. Nobody can say for sure, but I do urge people to keep an open mind. When you hear people dogmatically say it's bound to be many decades in the future, be skeptical. It might be that a single breakthrough will unlock many issues, a bit like calculus in the 17th century, developed by Newton and Leibniz, unexpectedly was the key to so many fields of science. A bit like quantum mechanics broke through after 1927 when Heisenberg, Schrödinger, and Dirac had come up with their initial breakthroughs. Then, as Dirac said, at that stage, even a second-rate physicist could do first-rate work. A number of breakthroughs then caused absolute speed up. And another example, neural networks after 2012, as I mentioned, led to breakthroughs in CNNs, RNNs, and later generative adversarial networks. After this kind of key breakthrough, what would previously have been thought likely to take 100 years could happen much more quickly. Of course, it's possible that what looks like a new breakthrough, which initially has people excited, might not work. So that's another reason to be unsure. But let me put some prediction on the table. I can't give a definite prediction because of the uncertainties, but I do think there's at least 10% likelihood that as early as 2025, we'll look back at today's 2020 software systems and say, oh, but we didn't know about such and such a thing then. That's why they were so weak compared to the AI that we'll have by that time in the future. And I think there's a 50% chance of artificial general intelligence by 2050, and subsequently artificial superintelligence pretty soon after that. Alan Turing, one of the true
Hello.
fathers of artificial intelligence.
Sorry,
Hello.
sir. Hello.
Yes, I'm
Hello. Sorry to
33
disturb you,
minutes in.
sir.
Yes, sure.
Yes, sir. So last 5 minutes.
Last,
Sir,
sorry.
so last
10
5 minutes.
Last 5
5
minutes.
minutes.
That's
5
fine.
minutes.
Yes, sure.
Yes, sir. Yeah.
So
Thank you, sir.
according to Alan Turing, he said that there's nothing in the human mind that could not be simulated by AI. And once they have started to talk to each other, they will be able to sharpen each other's wits. What one AI learns, he didn't use that term, he talked about machine learning. They would quickly leave humans behind, and we would expect the machines to take control. He said that as long ago as 1951. Some of his arguments in his papers are still very valid today. Sadly, he died far too soon. He was ostracized in his life. He probably committed suicide. But one of his colleagues from the days of code breaking during the Second World War and subsequently worked with him on the first computers in Manchester in England, I.J. Good, subsequently wrote down the argument more carefully in a paper in 1964, which has caused many people's lives to be changed when they read these words. Let an ultra-intelligent machine be defined as a machine that can far surpass all the intellectual activities of any man, however clever. Since the design of machines is one of these intellectual activities, an ultra-intelligent machine could design even better machines. There would then unquestionably be an intelligence explosion, and the intelligence of man would be left far behind. At first, he said this would be good, because we would no longer need any other invention. Any problem we were struggling with could then be given to that ultra-intelligent machine. But there's a comma there before he goes on to wonder and worry, provided the machine is docile enough to tell us how to keep it under control. And later in his life, and he did live a long life, he was more and more pessimistic that we could ever keep control of these systems. I'm short of time. I won't be able to talk through this. I will miss this as well. I will just quickly then talk about the need to think more carefully about software in advance and what can go wrong with it. There are 5 things that can go wrong with powerful AI. First of all, it may simply have bugs. I'm sure you know, a secret. Software sometimes has bugs. Even software written by very clever people in very successful corporations has bugs. You may have seen this video of a takeoff of a rocket at the end of 10 years of development. This was a European rocket. It had $7 billion of investment, which is a lot in 1996. And just a few seconds after takeoff, it veered sideways and exploded, with all the rocket and cargo being lost. Why? Because of, in this case, a bug, a simple bug, as it turns out, a simple bug in complex software. A number was moved from one format to another where there was no longer enough space to store the number properly. It lost its significant digits. That was an example of a simple bug in complex software. In reality, the complex software often has complex bugs because of complex interactions. The problem with much of today's AI, deep learning, is it is opaque. Nobody's quite sure how good the results are. They seem to work, and so we use them, but they can have bugs lurking, often bugs that lie undetected until too late. Even when the software is correct, it can have an incorrect specification. We write a specification
which will be more faithful and more useful for the future AI.
When you're quite right, the cloud has been a big driver of progress, because the cloud has allowed lots of computing resources to be available remarkably cheaply due to the strong competition between different providers of computation on the cloud, the competition between Microsoft and Google and Amazon and so on. So that has been an important breakthrough. However, people are still looking at new chip designs. There's the startup in Britain called GraphCore, which has put a huge amount of effort into designing a new chip that can do some deep learning calculations more effectively and more efficiently. It's expensive today, but in the future, probably the price will come down. Quantum computing has not yet managed to do more than, I think it's about 53 qubits. We need many more than 53 to do significant results. That could break through in 18 months, or it might take 5 or 6 years. We don't know. And again, it will be expensive when it starts, but over time, if it's commercially significant, people will find the ways to go cheaper. But you're right. The problems we're addressing are actually growing exponentially in complexity. So we can't just say, hey, greater exponential computing power will solve our problems. There is a race, complexity of problems versus complexity of computing, which is why we need to go beyond simple brute power. It's why we need clever new algorithms as well. It often is the improvements in software that has the biggest improvements. If you look at how chess computers have improved since 1997, when Deep Blue first beat the world champion in a match, Garry Kasparov, most of the improvements in chess computing since then have been from improvements in the software rather than just the hardware.
Okay. Thank you very much. These were the important 2 questions from my side. It was excellent presentations and really inspiring us to move towards the AI world and data science. Thank you very much, Dr. Wood.
My pleasure.
From my side. Yeah.
Thank you, sir.
Over to Trupti.
Over to you, Kulkarni, sir.
Thank you very
Over
much,
to you,
David, sir.
Kulkarni, sir.
Thank you, madam.
Yeah.
Thank you very much, David, sir. Listen to you and reviewing your slides are always a great pleasure. You are super AI for us, and your precise, concise paradigm presentation is always great to learn from us. Thank you for adding that G and S AI to make it as AGI and ASI. I'm sure people will definitely realize that ASI is not like a Frankenstein, but it's the reality with lot of sentience. Thank you very much, sir. Having a nice presentation from you here. Dear friends, today we are now heading towards our day 1 schedule in the morning schedule. And today we are having the 4 speakers among us. One is Mr. Patil from Canada, Mr. Akshay Bonde from Singapore, Dr. Parishit Male from Pune, and Dr. David Wood sir from London. And today we have seen what is AI to what is super AI. So thank you very much all of you for doing this honor. I am very much grateful to the organizer teams, especially Dr. D.C. Khanna sir, Dr. Musmade sir, Dr. Priti Patil madam, and Dr. Kotawar sir. And I am very much thankful to Vice Principal madam as well as Principal sir, honorable management for giving me this opportunity. Pleasure was all of us to listen to what is AI's application in various engineering domains. Thank you